And with this one of the easiest and highly creative topics is maintenance direction just says go over the NCRT like 3 to 4 times. I'm just gonna brief the stuff in NCRT. NCRT direct lines mostly the so go over the surface chemistry chapter 3 4 times. Uh, so today I'm gonna cover adsorption and catalysis. Tomorrow, in the next week, it's gonna be collapse. Uh, Adsorption is essentially accumulation of molecular species at the surface rather than the bulk of solid or liquid. The molecular species or substance which concentrates on accumulation at the surface is absorbed, and the material of the surface of which the adsorption takes place is called adsorption. So, okay, your molecules are being accumulated at the surface and they are not getting sucked into the surface of the body, which say you're dipping a chalk in an ink bottle or chalk in an see that the chalk చుట్టూ బ్లూ కలర్ కానీ బ్లూ కలర్ బ్రేక్ చేస్తే you'll see water inside. It's బయట బ్లూ కలర్ ఉంటుంది లోపల it's just water. It could be white color. So the ink molecules have just been absorbed onto the surface of the chalk. Here the ink is adsorbate and the chalk piece is absorbed. It is clear from above examples that solid surfaces can hold the gas or liquid molecules by virtue of absorption. The process of absorb substance from a surface on which it is absorbed is called adsorption. Usually, solid surfaces are good adsorbents because they have definitive surface area, strong molecular forces, strong adsorptive forces. So solid surfaces they can hold both gas and adsorption and adsorption. To simply put, the chalk is example for your ink molecules got adsorbed onto the chalk piece surface, and your water got absorbed into the chalk piece. That's what absorption. The substance is concentrated only at the surface and does not penetrate through the surface to the bulk of adsorbent, while in adsorption the surface is uniformly distributed to the bulk of the solid. Both adsorption and absorption can take place simultaneously. The term is called sorption. Like the chalk piece and ink example is not sorption exactly. When you're absorb by the same substance then you say that the substance is sorted onto the adsorb. Another example of absorption, water vapor. Water vapors are absorbed by nitrous CaCl2 but adsorbed by silica gel. Silica gel packets తీసుకుంటే they adsorb the moisture surface మీద వస్తుంది water vapor. But CaCl2 it absorbs and turns into hydrated CaCl2. And hydrous CaCl2 turns into hydrated CaCl2. It's turns from anhydrous form to some glowy crystal form. Right? In other words, in adsorption, the concentration of adsorbate increases only at the surface of adsorbent, not in the bulk. While in absorption, the concentration increases throughout the bulk. Mechanism of adsorption. To simply put the two-page, three-page explanation, it's basically when you take your adsorbent surface, in like the molecules in the bulk experience uniform forces. Like they have molecules surrounded around them. So చుట్టూరా ఫోర్సెస్ ఉంటాయి అండ్ దోస్ వుడ్ బి ఈవెన్ అవుట్. కానీ సర్ఫేస్ మాలిక్యూల్స్ ఏమో ఓన్లీ ఒక సైడే అట్రాక్టివ్ ఫోర్సెస్ ఉన్నాయి, మిగతా సైడ్ దే డోంట్ హ్యావ్ ఎ ఫోర్స్. సో ఇప్పుడు ఇంకొక మాలిక్యూల్ వెన్ ఇట్ ట్రైస్ టు అప్రోచ్ ది సర్ఫేస్, దెన్ ఈ అన్బ్యాలెన్స్డ్ ఫోర్సెస్ అన్నవి దే పుల్ ది మాలిక్యూల్ కమింగ్ టువర్డ్స్ ది సర్ఫేస్. బేసిక్లీ ఒక ఫీల్డ్ లో ఒక చార్జ్ చేస్తున్నట్టు ఇఫ్ యూ ఆర్ పుటింగ్ స్క్రిప్ట్స్. Otherwise, okay, this surface లో you will have unbalanced forces. So ఎప్పుడైనా molecules approach అయితే these unbalanced forces try to pull uh, the molecules towards the surface. Towards the surface. Towards the surface. That's the molecular explanation for adsorption. Thermodynamic explanation is adsorption is an exothermic process, and like so delta H negative, and the entropy during adsorption decreases. Right? ముందు the molecules are random పైన అలా తిరుగుతుంటాయి in the surface, but ఇప్పుడు adsorbent molecules are more arranged onto the surface of adsorbent. So the entropy randomness reduces, the entropy reduces. So delta is also positive, delta is also negative. So ఇప్పుడు delta H should be more negative. సో ఎక్కువ హీట్ రిలీజ్ అయితే దెన్ యూ కెన్ కాల్ ది అబ్సార్ప్షన్ స్పాంటేనియస్. లైక్ ది అబ్సార్ప్షన్ హ్యాపెన్స్. యూ కెన్ సీ ది అబ్సార్ప్షన్ వెన్ దెర్ ఈస్ మోర్ హీట్ రిలీజ్ వెన్ కంపేర్డ్ టు ది రిడ్యూస్ ఇన్ ర్యాండమ్నెస్. లేదు అంటే ది ప్రాసెస్ డజంట్ హ్యాపెన్, యూ కెనాట్ సీ ది అబ్సార్ప్షన్. లైక్ డెల్టా జీ లెస్ దెన్ 0 ఉంటే డెల్టా జీ ఇస్ డెల్టా హెచ్ మైనస్ టీ డెల్టా ఎస్. సో దట్ ఈస్ types of adsorption: physisorption, chemisorption. Physisorption, to briefly put them, these are the differences. Physisorption arises due to van der Waals forces. Chemisorption, chemical bond formation. Physisorption, not specific in nature, highly specific in nature. Reversible, irreversible, depends on nature of gas. More easily liquefiable gases are adsorbed. Also depends on nature of gas. More easily liquefiable gases are absorbed readily. That's because of the forces of attraction. Uh, that's an important point. Your SO2, these are more, SO2 is more easily liquefiable than H2, SO2, CO2. These have higher forces of attractions. So, ఎక్కువ attractions అయ్యి surface కి absorb అవుతాయి. Another thing, liquefy అయితే your equilibrium absorption is also, physical absorption is a reversible process. So equilibrium ఉంటుంది. When your gases are liquefied, the reaction goes in forward direction for equilibrium to maintain. So enthalpy of adsorption is low, enthalpy of adsorption is high, because absorption లో you are having bonds ఇక్కడ, just van der Waals forces. Low temperature is favorable for adsorption, decreases with increase of temperature. The reason you want your molecules increases. So అప్పుడు ఆ వాటర్ వాల్ ఫోర్సెస్ దే won't be able to hold these molecules really enough. So తక్కువ టెంపరేచర్ లో వాటర్ వాల్ ఫోర్సెస్ యాక్ట్ more effective since the kinetic energy of adsorb is less. So low temperature favorable. High temperature is favorable for chemisorption. It increases with increase of temperature. But the chemisorption is an end process, not in a like a chemical reaction you need activation energy. You need to cross the activation energy barrier. Right? So activation temperature is the you are supplying energy high temperature. So you can cross the activation barrier easily. No appreciable activation energy is needed. High activation energy is submitted. Depends on the surface area. It increases with increase of surface area. It also depends on the surface area. It will increases. Surface area increases, you can have more slots or molecules can come on to and come and latch onto the surface. More absorption. And physics it's a multi-layer process. So absorption extends like multiply. It's not like increases. It increases more than chemisorption is a unilayer process. Okay. It results into multi-molecular layers on absorbent surface under high pressure. High pressure, high pressure, more layers, low pressure, less. It results in unimolecular layer. Adsorption isotherms, Freundlich adsorption isotherm. That those are the two equations. Both are the same. One log of another. Freundlich isotherm explains the behavior of adsorption in an approximate manner. This is not the accurate. There is another adsorption isotherm called Langmuir, not there in NCRT, but that is more better than this. Factor 1 by n can have values between 0 and 1, probably 0.1 to 0.5. This equation is the x by m holds good over an infinite range of pressure. Timer absorption is good for a wide range of pressures. That is also approximate isotherm, but it's good for wide range. 1 by n is both the conditions are supported by experimental results. The experimental isotherms always seem to approach saturation at the high pressure. It's 1 by n 0. This cannot be explained by Freundlich isotherm because the 1 by n or 1 by n reaction because it fails at high pressure. Those are the graphs. Graphs are important, especially absorption from solution is Freundlich approximated this thing by replacing the partial pressure of adsorbent by concentration, equilibrium concentration of adsorbent. Adsorbent. Adsorbate. Mm, Solution phase adsorbent depends on decreases with increasing temperature. Just like this is uh, increases with increasing surface area. Absorption decreases on concentration of solute in the solution. The extent of adsorption depends on the nature of adsorbent and sorbate. Of course, it's precise mechanism of adsorption from solution is not Freundlich's equation approximates this figure. Applications of adsorption. We have plenty of applications for adsorption. There are some these available. Production of high vacuum, gas mask, humidity control, uh, removal of color dyes, heterogeneous catalysis, uh, gas separation by diverse method, uh, medical treatments, growth flotation process, see this adsorption indicators, new type of indicators, chromatographic analysis. Chromatography is based on absorption and absorption. Absorption phenomena essentially, and but absorption also is catalysis. Simply speaking, your reactions move faster when there is a presence of the third party substance. The concentration of third party substance is not very the overall reaction, but the presence of the third party substance enhances or the presence of third party substance enhances the speed of your reaction. Then అప్పుడు ఆ థర్డ్ పార్టీ సబ్స్టెన్స్ ని కాల్ as catalyst. Substances which accelerate the rate of the chemical reaction and themselves remain chemically and quantitatively unchanged after the reaction are known as catalysts. And the phenomenon is known as catalysis. Uh, promoters, phenom- promoters and poisons. Promoters are substances that enhance the activity of catalysts while poisons decrease the activity of. For example, Haber's process for the manufacture of molybdenum acts as a promoter for iron, which is mixed. Adding iron is as a catalyst is enough for molybdenum enhances these being. And poisons in the causes sometimes your processes are way too damn fast. Fast processing is slow చేయడానికి poison. కొన్నిసార్లు your కొన్ని reactions కి some elements and some molecules in your atmosphere act as catalysts, కానీ you don't want the reaction to happen. So side reaction cause the atmosphere లో catalyst boost చేస్తుంది. So when you code the reaction the poison, అప్పుడు your side reactions won't happen. Okay. Example, rusting of iron. Rusting of iron, they are sort of poisons. Can stop rusting of iron. Homogeneous and heterogeneous catalysts. Basically, reactants in your catalyst same phase లో ఉంటే homogeneous, లేవు ఉంటే heterogeneous. Haber's process is heterogeneous. Homogeneous catalysis, so mostly your catalyst would be in gas phase or liquid phase, never in solid phase. Heterogeneous catalysis are very famous because let's see, homogeneous catalysis examples contact process, lead chamber process, SO2 plus O2 is SO3 in presence of. There is contact process for SO2 plus O2. That lead chamber process is and the solar gases. Hydrolysis of methyl acetate by hydrochloric acid is your esterification, ester hydrolysis. This is all liquid phase catalysis. So ester hydrolysis can be done in acid phase and basic phase also. Acid acidic medium and basic medium. So this is acidic medium. Like, hydrolysis of sugar is catalyzed by H+. Hydrolysis of all are liquids. Heterogeneous catalysis, your contact process. Instead of your NO gas, you're using that. Uh, Nitrogen Haber's process. Third thing, Ostwald's process. Back of from Haber's process in using of Ostwald's process. Haber's process is the biggest industrial process, like most quite commercial. Hydrogenation of vegetable oils, your monospati production. Basically, hydrogenation reaction, your metal surfaces are good catalysts for hydrogen reactions. Okay. Your metal surfaces can hold the hydrogen molecules, hold like very large amounts of hydrogen molecules. There is a name for this in hydrogen molecules. Basically, your vegetable oils are hydrogenated to vegetable. So, catalysis can be explained in terms of absorption theory. This is the third theory. There are two other theories. One is intermediate compound formation theory. I don't This theory is discussed in NCR. This theory is discussed in NCR. It is very shortly. Suppose your A and B are reacting to form AB. And how does that happen in presence of a catalyst? See the figure here, right? Catalyst surface, your molecules are approaching. That step is called diffusion of reactants to the surface of catalyst. Now, your A and B are latched onto the surface. Now, this step is called adsorption of reactant molecules on the surface of catalyst. ఇప్పుడు surface మీద latch on అయ్యాక so your A and B are active. ఎందుకంటే they are absorbed onto the surface. They have high energy due to the unbalanced forces. So they can form the bond much easier. Your surface of molecules are basically called active site because of this reason. When molecules approach and absorb onto the surface of uh, surface sites, they become more active and more easier to react because they are in high energy. So if they absorb they form their bond. That's called occurrence of chemical reaction on the catalyst surface through formation of an intermediate ఎందుకంటే ఏవి బాండ్ ఫామ్ అయింది కానీ ఇట్స్ లాస్ట్ ఆన్ టు ది surface. So it's not exactly a molecule. That's an intermediate state. ఇప్పుడు your AB gets detached from the surface. This step is called desorption of reaction products from catalyst surface and thereby making the surface available again for more reaction to occur. It gets detached and get దూరంగా వెళ్ళిపోతుంది సర్ఫేస్ నుంచి. జాబ్ ఈస్ డన్. అక్కడ నుంచి ఏపీ రియాక్షన్ మాలిక్యూల్స్ వస్తున్నాయి, ఒక ప్రోడక్ట్ మాలిక్యూల్స్ చేసుకోవచ్చు. This is called diffusion of reaction products away from catalyst. 5 steps. The surface of catalyst, unlike the inner part of bulk, has free valencies which provide the safer chemical forces of attraction. When a gas comes in contact with such a surface, its molecules are held up there due to loose chemical combination. If each other resulting in formation of a new molecules, sorry, if different molecules are adsorbed side by side, they may react with each other, resulting in formation of new molecules. Thus, formed molecules may evaporate, leaving the surface for fresh reactant molecules. This is the macromolecular view of the adsorption. The first thing is the micromolecular view, the 5 steps. This theory explains why catalyst remains unchanged in mass and chemical composition at the end of reaction and is effective. But this theory has a drawback, not as a drawback. This theory cannot explain the action of promoters and poisons onto catalysts. So basically, promoters and poisons to explain this, we don't have a theory right now, at least in NCERT. Coming to the right, the increase in concentration of reactants on the surface increases the rate of reaction. Basically, equilibrium. ఇక్కడ ఎక్స్ప్లెయిన్ చేసింది ఇట్ ఈస్ సార్ట్ ఆఫ్ లైక్ ఫిజికల్ అబ్సార్ప్షన్, నాట్ ఎగ్జాక్ట్లీ ఫిజికల్ physics option, but something like physics option. So concentration, it's a equilibrium sort of process. Reactant molecules add చేస్తే your reaction moves forward, rate increases. Adsorption being an exothermic process, the heat of adsorption is utilized in enhancing the rate of reaction. Of course, bond form అయ్యేటప్పుడు you will need to cross the activation barrier. Some of that energy required for activation crossing the barrier is supplied by heat of absorption. మిగతాది you're just gonna normal chemical reaction conditions, temperatures and pressures. It, however, doesn't explain the action of catalysts and catalytic promoters and poisons. Important features of solid catalysts. As you can see, this theory is for solid catalysts. The activity of a catalyst depends on the strength of chemisorption to a large extent. The reactants must get absorbed reasonably strong on the catalyst to become more active. However, they must not get absorbed so strongly that they are immobilized and other reactants are left with no space on the catalyst surface for the absorption. That's understandable. It has been found that for hydrogenation reaction, the catalytic activity increases from group 5 to group 11 metals, with maximum activity being shown by group 7 to 9 elements of the periodic table. Yes. మీద ఇంతవరకు క్వశ్చన్ అడగలేదు, సో దేర్ ఈస్ ఏ ఛాన్స్ దట్ ఈ మెయిన్స్ లో అడగచ్చు. So that's one thing. Activity and selectivity. ఎక్కడ selectivity? Organic law, you will see this, right? Selectivity, regioselectivity, and regiospecificity. అక్కడ why అక్కడ ఎందుకు దే నీడెడ్ regiospecificity and regioselectivity, ఆ ఎక్స్ప్లెనేషన్ ఈ ఎక్స్ప్లెనేషన్ కొద్దిగా సిమిలర్ ఉంటాయి, ఎక్సెప్ట్ ఇక్కడ regiospecificity కాదు, you will have activity. The quantity matters here and the selectivity matters. Think similar to the organic chemistry, understand the absorption theory. The selectivity of a catalyst is its ability to direct a reaction to yield a particular product selectively when under the same reaction conditions many products are possible. Selectivity of different catalysts for same reactants is different. For example, starting with products H2 and CO using different catalysts, we get different products. This is very much, very, very important. A lot of questions are asked. Nickel అయితే you'll get methane, your copper in presence of ZNO and Cr2O3, you'll get CH3OH, that is like a promoter. ZNO Cr2O3 acts as a promoter for your copper. If you are keeping copper alone, copper is like weaker catalyst than nickel based on the above points. The group 5 to 11 low, 7 to 9 with strong. Nickel is from 7 to 9, copper is your. I don't. Copper is weaker catalyst than nickel, so you'll have formaldehyde. Nickel low, you have strong hydrogenation. Copper in presence of promoter, moderate hydrogenation, alcohol. Uh, on copper alone, you'll have aldehyde. Thus, it can be inferred that the action of catalyst is highly selective in nature. As a result, a substance which acts as a catalyst in one reaction may fail to catalyze the other reaction. ఇక్కడ this example is based on the selectivity based on energy. ఇక్కడ లో you'll have high absorption, so high energy of absorption supply అయింది కాబట్టి మల్టిపుల్ హైడ్రోజనేషన్స్ అయ్యి కాపర్ లో అంత ఎనర్జీ ఉండదు బికాస్ ఆఫ్ లో నెంబర్ ఆఫ్ అబ్సార్ప్షన్స్ సో లో ఎనర్జీ లో నెంబర్ ఆఫ్ hydrogenations. So this is based on energy and the latching onto it. ది అబౌవ్ పాయింట్ అక్కడ స్టిక్ ఆన్ అయిపోయి ఉండిపోతుంది. ఆ రెండింటి బేస్ చేసుకుని దిస్ ఈజ్ వన్ సెలెక్టివిటీ. దెర్ ఈస్ అనదర్ సెలెక్టివిటీ షేప్ సెలెక్టివ్ catalyst by zeolites. The reaction zeolites are like ALO trialuminosilicates zeolites. The reactions taking place in zeolites depend upon the size and shape of reactant and product molecules as well as upon the pores and cavities of zeolites. They are found in nature as well as synthesized for catalytic selectivity. Basically, your zeolites have a honeycomb structure of ALOSI bonds. Honeycomb framework ఉంటుంది. మన రియాక్టర్ మాలిక్యూల్స్ అన్నవి దిస్ ఈజ్ లైక్ ఏ సీవ్. ఒక సీవ్ ఏమంటుంది బేసిక్లీ ఒక జల్లెడ లాగా. యువర్ జియోలైట్స్ ఆర్ లైక్ ఏ జల్లెడ. జల్లెడ నుంచి యూ కెన్ పాస్ లైక్ టీ పాస్ లైక్ షుగర్ పాస్ అయితే కానీ యూ కెనాట్ పాస్ ది టీ లీవ్స్ అండ్ ఆల్ కదా. కరెక్ట్ ఆ షేప్ అవన్నీ ఉండాలి. లైక్ జియోలైట్స్ ఆర్ లైక్ సీవ్స్, సో only specific reactants can latch onto the zeolites. Specific shape undali fit అవ్వాలంటే, otherwise it will just pass through in catalytic action. They are found in nature as well as synthesized for catalytic selectivity. Zeolites are being widely used as catalysts in petrochemical industries for cracking of hydrocarbons and isomerization. An important zeolite catalyst used in petroleum industry is Edison 5. Converts alcohols directly into gasoline by dehydrating them to give a mixture of hydrocarbons. General point. Another example for selectivity is enzyme catalysis. Last topic of the day after fully time take devices. Enzymes are thus biochemical catalysts. The phenomena is known as biochemical catalysis. Basically, enzymes are found in your body. They are like catalysts for reactions happening in the human body. So many enzymes have been obtained in pure crystalline state from living cells. This is not like preparation, extract it. However, the first enzyme was synthesized in the laboratory in 1960. This is the artificial synthesis. ఇప్పుడు your enzymes study of enzymes is a very widely popular study ఎందుకంటే your medicines are based on enzyme catalysis. Your medicines are essentially poisons for many enzyme catalytic reactions. Your paracetamol అన్నది it stops the reaction of your fever అప్పుడు ఏదో రియాక్షన్ అవుతుంది బాడీలో by that your temperature increases. Viral fever అయితే you will have like some virus interacting with right. Antibodies virus తో ఫైట్ చేస్తున్నప్పుడు you have any exothermic reactions అన్ని కూల్ డౌన్ చేయడానికి like those reactions are antibodies reactions are promoted by enzymes also. ఇప్పుడు ఆ ఎంజైమ్ యాక్టివిటీని తగ్గించడానికి యూ విల్ యూస్ పారాసెటమాల్ జస్ట్ పారాసెటమాల్ ఇట్లాగా సిట్రిజిన్ ఆల్సో ఈజ్ అన్ ఎంజైమ్ పాయిజన్ ఇట్లాగా basically our medicinal study is based on enzyme catalysis, so it is very important. ఎంజైమ్స్ కి చాలా ఎంజైమ్ catalysis కి చాలా ప్రాసెసెస్ ప్రాపర్టీస్ ఉంటాయి యాజ్ అ మెకానిజం అండ్ దీస్ ఆర్ సమ్ ఎగ్జాంపుల్స్ highly important. Please remember this. Characteristics of enzyme catalysis: highly efficient. Normal catalysis కంటే this is like 10 power something times higher depending on the enzymes. Highly specific in nature, more specific than zeolites per se. Only one or two reactants ni accept చేసి catalyze చేస్తుంది. This is also because of the enzyme catalysis mechanism. And then you can understand why it is highly specific. Highly active under optimum temperature. ఇక్కడ high temperature కాదు, low temperature కాదు. This is not exactly like this option or this option. This is a combination of both and is highly complicated to explain why the highly complicated to explain why enzyme catalysis is enzyme catalysis అన్నది maximum అన్నది ఒక optimum temperature లో అయింది అని ఎక్స్ప్లెయిన్ చేయడానికి ది మెకానిజం ఈజ్ హైలీ కాంప్లికేటెడ్. ఎగ్జాంపుల్స్ ఉన్నాయి. ప్లీజ్ లుక్ ఎట్ ఇట్. Optimum temperature is 298 to 310 Kelvin. So basically, human body temperature. Highly active under optimum pH. Same thing, highly complicated to explain. Optimum pH value is 5 to 7. Again, human blood pH. Increasing activity in presence of activators and coenzymes. Enzymes have activators and coenzymes also. The enzymatic activity is increased in the presence of certain substances known as coenzymes. It has been observed that when small non-protein, otherwise called as vitamin, is present along with an enzyme, the catalytic activity is enhanced considerably. Activators are basically metal ions. These metal ions, when weakly bonded to enzyme molecules, increase their catalytic activity. Amylase in presence of sodium chloride are so amylase has Na plus as activator. Influence of inhibitors and poisons. This is my point here. Like ordinary catalysts, enzymes are also inhibited or poisoned by presence of certain substances. Inhibitors or poisons interact with the active functional groups on the enzyme surface and often reduce or completely destroy the catalytic activity of the enzymes. The use of many drugs is related to their action as enzyme inhibitors in the body. On general point, medicinal drugs and narcotic drugs are basically the same thing. Kani, they act on different things. Your medicinal drugs, they poison the enzymatic reactions which harm the body. Your narcotic drugs, they poison the enzymatic reactions which help your body. Bodylo, there are some enzymatic reactions in the brain, in the heart, in the liver, in pancreas. Very lot of reactions, necessary enzymatic reactions. Narcotic drugs, they poison these reactions. So the body starts to fail when you ingest narcotic drugs. Medicinal drugs help in the contrary way by stopping the harmful reactions. Mechanism of enzyme catalysis. This does not explain the uh, optimum pH and temperature. This mechanism explains the specific nature of the enzyme catalysis. You can see that step one, binding of enzymes to substrate to form an activated complex. ఇప్పుడు సబ్స్ట్రేట్ లో you will have like certain slots ఉంటాయి. Lysiolase లో సివ్ కి సర్టన్ రియాక్టెంట్ స్ట్రక్చర్ ఉండాలి కదా, అక్కడ షేప్ ఉండాలి. ఇక్కడ యుల్ నీడ్ ది సర్టన్ ఫంక్షనల్ గ్రూప్స్ ఇట్సెల్ఫ్, ఫంక్షనల్ గ్రూప్స్ అండ్ ఇట్స్ మాలిక్యులర్ అరేంజ్మెంట్స్. సబ్స్ట్రేట్ తో బైండ్ అవ్వాలంటే ది అప్రోచింగ్ ఎంజైమ్ షుడ్ బి highly specifically arranged with respect to the substrate. సింపుల్ చెప్పాలంటే సబ్స్ట్రేట్ ఈస్ లైక్ ఎ లాక్ అండ్ ఎంజైమ్ ఈస్ లైక్ ఏ కీ. ఒక లాక్ కి యూ కెన్ ఓన్లీ హ్యావ్ ఏ సర్టెన్ కీ arrangement. So basically this mechanism is also called as key lock mechanism. Step 1, binding of enzyme to substrate to form an activated complex. Key inserted into the lock. Step 2, decomposition of activated complex to form products. You turn the key, your lock gets modified. Though your lock is like locked, now it's unlocked. Basically, substrate gets broken up into products. Substrate modified, your enzyme doesn't get your enzyme, otherwise your key doesn't get modified. That's it with enzyme catalysis. Kinda the table is some of the industrial catalysis processes. By the way, this is important. పైన ఉన్న ఎంజైమ్ కెటాలసిస్ రియాక్షన్ అనేది it's highly complex. వాటి మీద there was a question related to that 10 chemical constitutions. Some industrial catalytic processes. First one, Haber's process, Ostwald process, contact process. మూడు already discuss చేసుకునే. They have their respective catalyst, iron, molybdenum promoter, some certain conditions. Platinized asbestos temperature, platinized asbestos or vanadium hydroxide. Please have a look at it later. Now moving on to PYQs. I follow this Arihant book ఎందుకంటే నాకు వేరేవేం దొరకలేదు. There are plenty of JEE mains books in market and online లో కూడా they uploaded the JEE mains papers. So these all previous JEE mains papers for enhancing your speed and accuracy and to know how the questions are asked. So it's chemistry based one. మీ ప్రిపరేషన్ కి try to solve the papers as a whole. ఎందుకంటే it just helps when you solve the మొత్తం paper like 30 questions paper or 90 questions paper solve చేస్తే it is like creating the exam environment here. So this to solve the questions as a whole, not like chapters. Well, now hope it's visible. So, simplified absorption spectra of three complexes of Mn plus ion are provided below. Their lambda max values are marked A, B, C respectively. The correct match between the complexes and their lambda max values is. This question is a cross question between coordination chemistry and food science. Absorption spectra is a topic of coordination chemistry. So, so better. Okay, never mind. Lambda ఎక్కువ ఉంటే your lambda is firstly proportional to energy of adsorption. Lambda is inversely proportional to absorption. Question. Ah, yep. The y-axis readings are necessary for us right now. The absorption extent depends highly upon many factors, but lambda max only varies with the energy of absorption. Energy of absorption is your delta naught CFSE energy in this case. So దేనికి high CFSE అంటే that has low lambda naught. High CFSE is based on the strength of ligands. Energy అయితే 1 greater than 3 greater than 2. So answer is uh, basically 2 కి ఎనర్జీ తక్కువ ఉంది సో లాంబ్డా హై ఉండాలి. C is 2, B is 3, A is 1. This is optional. Okay, my bad. Strength of island, strength of ligands here. NH3 is stronger than NCA, stronger than F6. F float. ఎందుకంటే NCS లో your nitrogen is donating here. Sulfur thiocyanate, right? Isothiocyanate. Isothiocyanate lo your nitrogen is donating, but that lone pair is getting want to sulfur and carbon. So అమోనియాకి ఎక్కువ కనెక్టింగ్ నేచర్ ఉంది దాని సేస్ ప్లీజ్ suppose the coordination chemistry at strength of lions. For now, 3 greater than 1 greater than 2. So C కి 2, B కి 1. Explanation ఇచ్చాను. For more clarity, please suppose the strength of ligands in coordination. Second question, among the following, the incorrect statement about the colloids not right. Peptidization not right. No. Correct option colloids. I forgot to mention. Surface chemistry knows question say it would be like colloidal state. Colloidal state is the important topic because it's the gas undergoes physical absorption on its surface and follows the Freundlich absorption isotope. Your N is 0.5. Absorption of gas increases with temperature. Your Freundlich absorption isotherm is based on physics option. So absorption increase అవ్వాలి అంటే there should be a decrease in temperature. And your X is the molecules of absorption, molecule mass of molecules absorbed. Your mass M is the total mass of absorbed molecules. So pressure పెరిగితే X పెరిగితే absorption పెరిగిద్ది. To speak in a theoretical sense, pressure పెరిగితే your molecules get like in a way they get restricted or they get forced to absorb onto the surface. Theoretical. Yeah. Speaking in a mathematical sense, equation లో pressure పెరిగితే so absorb. I hope you understand the theoretical and mathematical. And temperature the అన్నది can only explain by theoretical sense. Temperature పెరిగితే your absorption decreases. So option B. Sixth question, direct question. I'm just gonna give it. Exactly చదువుకునే తెలుసుకున్నా. Seventh question, number of water molecules not coordinated to copper ion directly. Interesting question. Another cross question with support. See, coordination. CO4 dot 4 H2O. Hydrogen bonded with one. This is mentioned in chemical bonding in CRT. Reason is this is hydrogen bonding line. It's ఏంటంటే your copper is copper forms a complex with 4 H2O molecules in a square planar fraction. Or started your copper responded to 4 water molecules to form a tetrahedral complex. That's two. The complex your counter ion is SO4 minus 2. అండ్ ఇప్పుడు ఈ కాపర్తో జస్ట్ ఒక పాజిటివ్ ఛార్జ్ ఉంది కాబట్టి వన్ హైడ్రోజన్ గెట్స్ లైక్ హైడ్రోజన్ బాండెడ్. Polarities 100. So you can Not only your F in oxygen and nitrogen, your complex centers like uh, complex centers can also form hydrogen bonds with water molecules. So, question: number of water molecules are not coordinated to covalent directly. This is not coordinated. This is hydrogen bonded. So, answer is eighth question aerosol. Ninth question: absorption of gas follows Freundlich adsorption isotherm. The plot is shown x by m is proportional. Your equation early simplification x by m equal to k p power by so log x by m equal to log p sorry, k. K is not your equilibrium constant. K is just a constant plus 1 by n log p. So your 1 by n equal to slope is like y equal to c plus 1x log p is x 1 by n is n log kc log 1 by n is slope which is equal to 2 by 3. So x by n equal to k p or and 10th question provides 11th question. Uh, 11th question is based on the theory. Easily liquefiable gases are absorbed in water. Easily ఏ gases liquefy అవుతాయి. Okay, I didn't read the questions. Given four gases in their respective critical temperatures on the basis of data above, predict the following gases show least absorption on a definite amount of shock. Basically, least this point. This question is based on theory point. Easily liquefiable gases are more absorbed. Hardly liquefiable gases are less absorbed. And liquefaction extent is proportional to critical temperature. Critical temperature ఎక్కువ ఉంటే the gas is more liquefiable. Proportional to these critical temperature. This is proportional to adsorption. Proportional to liquefaction. This is proportional to T. So least adsorbed gas is least liquefiable, least critical temperature, H2. So last question, 15. Which of the following is not an example of heterogeneous catalytic reaction? Your hydrogenation of phosphol process. Haber's process heterogeneous. Hydrogen of vegetable oils heterogeneous. Oswald's process combustion of coal is also heterogeneous. So answer is your Oswald's. Please go forward. So that's it for today. Thank you. Uh, Please solve the questions from previous year's papers or National Test Abhyas app.